Okay, today we're going to continue to talk about the standard normal curve and that the area underneath of that curve is equal to 1. And we've used the empirical rule when we have values that are 1, 2, or 3 standard deviations away, because we have the 68, 95, 99.7 rule, the empirical rule. But let's say we want to find the area under the curve for something that's not a 1 or 2 or 3 standard deviations away from it. So let's say we have a z-score equal to a negative 2.13. I'd like to find the area under the curve. That's what this chart is for. Don't let this chart confuse you. It's extremely easy. This chart only has 2 things on it. It has z-scores, which are along the left side and the top. And it goes with negative z-scores, and this one is positive z-scores. Negative z-scores will, of course, be to the left of the mean, and positive ones will be to the right of the mean. This chart only gives us the area under the curve to the left of the z-score. So if I want to know if I have a z-score of negative 2.13, what is the area to the left of that underneath the curve? I'm going to use this chart, and I'm going to say negative 2.1 right here. And then the second decimal, this 3, is over here. So 0.03 gives me that second decimal. So I have to come down this column and across this row. And where they overlap, that is the area under the curve to the left of 2.13. So this area, say this is our negative 2.13. The area under the curve here would be 0.0166, or 1.66% of the population is below negative 2.13 z-scores. All right, well, that's easy enough. Let's try a positive z-score and see what we come up with. So let's just come up with a z of a positive 1.25. So let's just say this is positive 1.25, and we're going to look for that z-score. So I have a z-score of 1.2, so that's right here, and I have to come across this and then down to 0.05. So 1.25 has an area of, right here, 0.915. 0.915. Or that's the, I'm sorry, 0.9115. 91.15% of the population has a z-score less than 1.25. Or if I wanted to find to the right, you simply take 1 minus 0.9115, and that would equal 0.0885. Where's my pen? 0.0885. That would be the area over here. So if you have to find the area to the right of the z-score or above that z-score, you simply take 1 and subtract it from this area here. This is how you get percentiles when you take your SATs or your EOCs and you scored in the 91st percentile. That's exactly where this comes from. You scored better than 91% of the people. Okay, so let's take a look at some problems here. We have pennies, 500 pennies, and they found that they are normally distributed weights, and then we have a mean of 3.1 and a standard deviation of 0.014. So I want to know what percentage of pennies will weigh less than 2.96 grams. So the first thing you want to do is find your z-score. And z, remember, equals the raw score minus the mean divided by the standard deviation. So that's going to be 2.96 minus 3.1, and that's going to get divided by your 0.14. And this so happens just to come out to an actual -1. So we could use the empirical rule, but let's check it out and see what we get. please, you must draw the picture for every one of these problems. Draw your standard normal curve. Place your z-score on the standard normal curve and shade the area that you're looking for. Okay, so I got a z-score of -1. So now I got to go back to my chart and find a z-score of -1. Let's get rid of, whoops. Let's get rid of all this mess. Okay, so again, we're on the negative side, so we're going to be less than 50% because we're underneath a 0. So -1, that would be -1.0 right here. -1.00. So it's this guy right here, 0.1587. So 0.1587. So that means this area right here is 0.1587. Or the answer to the question is about 15.87% of pennies will weigh less than 2.96 grams. Okay, so that's pretty simple, straightforward. This one we want to find, it's going to be between 2.8 and 3.3 grams. Again, draw your picture. Label your 2.8 is above the mean. So this is 2.8. Well, let's find our z-scores first and use those, not our raw scores. But we want to find the area now between these two. So my z-score for 2.8 is going to be 2.8 minus 3.1 divided by 0.14, and that's going to give me -2.14. -2.14. I thought I was above 2.8. No, 2.8 is below the mean. Okay, that makes sense. All right, so let's go ahead now and put that on. So we're down here below the mean, -2.8. And let's find the other z-score here. So z equals 3.3 minus 3.1 divided by our 0.14. And that z-score should be 1.43. So 1.43. And there's my shaded region. Now, how am I going to find this area? When I find this z-score, it's going to give me the area the whole way down to here. So let's go find that one. So we're at 1.43. So I've got to go 1.4 positive 1.4 right here. And I got to go over to the 3.03 column. So that's going to be 0.9082. And 1.43. Sorry, it's the one below there. And 1.43. Here we go. It's this guy right here. 0.9236. So we come over here to our picture, and this one is 0.9236. So what's going on there? Okay, now when I find this guy, it's going to give me that area, all the area down here. Well, I'm going to take the big one and subtract off the small one, and that's going to give me what I have right here, what I'm looking for. All right, so we've got to find a -2.8. So we're going to go to our chart and now go to a -2.8. No, it's at 2.8 grams, but the z-score, did I have it written on there correctly? It should be -2.14. So that's not my z-score. My z-score here is a -2.14. All right, so we'll come over to our chart, get our -2.14, so -2.1, and come out to the fourth column, and it's going to be right where they intersect. and that's going to be my 0.0162. So we come back over here. This is 0.0612. So to find my answer, I'm going to take this 0.9236 and subtract the 0.0612, and that should give me 0.9074. So 90.74% of the pennies will weigh between 2.8 and 3.1 grams. So we can find to the left, we can find in between by taking the difference. Now we want to know what percentage of the pennies weigh more than 3.14 grams. 3.4 grams. So again, we're going to draw our standard normal curve, find our z-score. So z is 3.4 minus 3.1 all over our 0.14. So our z-score for this guy is 0.14. So it's just a little bit above the mean. So we got a positive 0.14 z-score here, and we want to shade up here. So let's go to our chart and find 0.14 z-score. So 0.14 z, it's going to be on my positive side. So 0.14. So 0.1 is the second column, or row rather. And here is the 0.04. So that's going to give me 0.14 at 0.5557. So we have to go back here. Okay, except it's not 0.14, it is 2.14. So this is 2.14. So basically, I could redo this and make it look a little better. That I'm not here. 2.14 will be up here a little further. And I want to be greater than 2.14. So let's go back to the chart and find the actual 2.14, not 0.14. So I go to 2.1, which is right here. And I come down to 0.04, which is right here. And it's that guy right there, 0.9838. 0.9838. So this area is 0.9838, but I don't want that area. I want 1 minus 0.9838, or 0.0162, or 1.62% of the pennies will have a weight greater than 3.4 grams. All right, so that's how we find the areas under the curve given a z-score. Well, we can go backwards then. If I want to find out what weight represents the 85th percentile, I want to know what's the penny weight that will give me 0.85 here. And that would be your 85th percentile. Well, remember, this chart only gives us two things. It gives us z-scores along the left side and the top, and the entire body is where we get our weights. So if I get a z-score, I just find the z-score, I come up with the weight in here. But if I'm looking for the area, then I'm going to use the inside of the chart. And if it's an 85th percentile, I'm going to be on the positive side. So I'm going to be over on this side. And I'm going to find the closest number to 0.85. So you can see you have to have this thing printed out. It's a little difficult to read this. Okay, so here is 0.8508. And this is 0.8485. So that's 15 ten-thousandths below, and this is 8 above. So this one is the closer one. So I'm going to take that one, and that is 1.0 and 0.04. So that will give you the z-score of 1.04 for the weight of, or for the 85th percentile. So that's our z-score for the 85th percentile, but we'd like to find the weight that represents that. So we go back to our formula. Z is equal to x minus mu divided by sigma. So we got 1.04 is our z-score. We know that. We don't know x, the weight. The mean is 3.1. And divide that by 0.14. So if I multiply both sides by 0.14 and then add 3.1 to both sides, just like we were doing before, I get a weight of 3.2456 grams. All right, well, give these a try. I'll put the homework on the Google Classroom. If you have any questions, please do not hesitate to give me a question on there, and I'll be happy to do them all for you. Have a great day.